And here we go in section 12.2. Welcome back. This is P-Dog Does Science for the next lecture in the Chapter 12 series. So we have 4 basic categories in chemical calculations. There are many others. I realize there's a typo here in the outline. You get the drift. The 4 basic categories. First one is mole to mole. We did those in 12.1. Okay, mass to mass, which is the more complicated of all of them, and we'll be doing those today. We'll also be doing an example of mass to volume and volume to volume. These are ridiculously easy, and you'll understand why when we finish today's lecture. All right, first up is a mass to mass problem. You are given one substance, and you are asked to convert to the mass of another substance. The first step is to convert your grams to moles of a starting substance. Okay, this starting substance is your given, and that's the value that you are given in the problem. Well, grams to moles, converting grams to moles, you guys have done this before. This is just back to our mole island. Voila. And here's gram island. So if you're given grams, you're planted here on gram island, and you convert to moles by dividing by the molar mass. Well, dividing by the molar mass is the same thing as multiplying by the reciprocal of the molar mass, which would be 1 over the molar mass. If you are confused on that, go ask your math teacher about what it's like to multiply fractions. But the basic idea is, let's say you have 18 grams of water. It's not a good example. Let's use 36 grams of water. And if we want to convert to moles, we are going to multiply by 1 over the molar mass. Or we divide by the molar mass. Okay, well, dividing by the molar mass is dividing by 18 grams per mole. But if we're dividing by this fraction here, we're really multiplying by its reciprocal. And that will give us 36 grams of H2O times 1 mole over 18 grams of H2O. And another trick here that I didn't show in the last video, but I think you guys should catch on to, is this. We want to be drawing this, noticing that there's a connection between these units here and these units down here, that they are always the same. So you drag these units, the grams of H2O, to the bottom of the next fraction, and miraculously, they are going to cancel with each other. That's the whole point to doing this, giving us whatever numbers are left and these units that are on the top of the last fraction. And we will continue to do that through all of our problems in this particular section. So, we start with converting grams to moles of a starting substance. Then, we use the mole ratio to convert to desired substance. Well, again, back to mole island, the mole ratio is just what we saw in the last video. That's where we take our moles of our given species, or whatever we're starting with, and we're converting to the moles of our ending species, which is the moles we are finishing with, and that's the moles of the given over the moles of the, under the moles of the target. Given on the bottom, target on the top. And so let's do away with mole lines for right now. And then the last step is then convert from moles to grams. And that's the exact opposite of this first process, where instead of dividing by the molar mass, we would multiply by the molar mass. All right, our example here is going to be, oh, it's not helping here. Our example here is going to be the cellular respiration equation, which is 1 molecule of glucose plus 6 molecules of oxygen is going to make 6 molecules of carbon dioxide and 6 molecules of water. So we start with 1.5 grams of, because I'm not going to write it all over again, this is glucose. So I will write it as GLU, and that was ugly. I forgive you. Please forgive me for having really poopy handwriting. 1.5 grams of glucose. All right, and the first step is to convert grams to moles of the given substance. Well, to do that, we illustrated that it was going to be dividing by the molar mass, and so the molar mass is going to go on the bottom. Carbon has 12 AMUs, so it's going to be 6 times 12 equals 72, and then 12 hydrogens is 12 times 1 equals 12, and then oxygen, there's 6 of those, times each one of those is 16, which equals 96, if I'm not mistaken. And then all those add up, that's 0, carry the 1, that's 80. So it's 180 grams of glucose is going to equal 1 mole of glucose, and lo and behold, there we are in moles. And so we're going to need to continue from there, and we go to our mole ratio. The mole ratio here, we take only from the coefficients. In fact, this is the only time we use the coefficients in our balanced equation, is in this mole ratio step. These units, if you remember, this unit went down here. This unit is going to go down here to give us 1 mole of glucose is going to equal, and our target was water. So water is here at 6. This number goes here on top, and that's going to be 6 moles of H2O. And that is our mole ratio step. Mole ratio using our coefficients. Then we continue on from there, because since this was our target, in fact, let me put these back in turquoise here, into blue, with that 6 right there. This is going to be times. Now we need to convert out of moles, so 1 mole of H2O has a mass of 18 grams of H2O. And then you multiply across it, and well, actually, lo and behold, again, we have these units going down here, 6 moles of H2O, 6 moles of H2O, and we get our grams of H2O, which is what we were looking for. Now, from this point, you can throw this all on your calculator, or because on the STAR test you don't get to use a calculator, you should start practicing canceling numbers. And so we are going to show that, notice that there's this 18 right here, and there's a 180 down here. Well, that will cancel to 10, and that will cancel to 1, so we can reduce fractions. This 10 is just like adding a decimal to, or moving a decimal over to the left, so I'm going to add it over here. And so what do we have left is a 1.5 times a 0.6, which is going to equal 0.9 grams of H2O, and that's our answer. And so as we move up, we took a skip and bumped you up. The next one we're going to do is the mass to volume problem. And so the first step is the same. In fact, the definition of it is we're given the mass of one substance, and we need to determine the volume of the other, and that is generally a gas. So we're going to convert grams to moles, same way we did before. Use the mole ratio, which is comes from the coefficients of the balanced equation. And then we're going to convert our moles to liters of gas, remembering that 1 liter of gas is 1 mole, where 1 mole of gas is equal to 22.4 liters. And we'll see you guys on the next page for those calculations. Okay, and so here is our volume problem that we are going to exhibit. We're going to, how many liters of H2 gas at STP can be produced from 9.1 grams of HCl? What do we find first? We find our given, and that is right here. We are given 9.1 grams of hydrogen chloride. Then we identify our target, and that is how many liters of H2. How many liters of H2 gas at STP can produce from 9.1 grams of HCl. So we start with 9.1 grams. 9.1 grams of HCl. We convert grams to moles. And so we divided by the molar mass. The molar mass of HCl is 1 times 1 plus 1 times 35.5 is 36.5 grams per 1 mole of HCl. HCl, remember that these units cancel. Those units go down here. And that takes us to our next unit, to our next step. Again, remember these units here come down here. And so that's going to give us moles of HCl, which should be the hint to tell us that this is the mole ratio step. We look up here. Oh, there's a 2 right there for the HCl. Our target now is liters of H2. Where's H2? It's right there. That's going to give us 1 mole of H2. And we are now in moles of our given. Again, use the tool. Moles of H2 are going to come down here on the bottom of this next fraction. Oh. And our next fraction is going to be mole of H2, and that's 1 mole of H2 because this is converting out of moles, but we're converting into liters of H2, and there are 22.4 liters of H2. We go through, we can multiply all this out. There's a little shortcut. The 9.1 and the 36.5 can roughly reduce to 1/4. And then we can start canceling stuff over here. The 2 is going to cancel with the 22.4, giving us 11.2. I know there's 1 2 that can cancel out of there, because that's going to make this 5.6. And there's another one. Okay, so we can cancel that 2 and make the 5.6 2.8. And that would be 2.8 liters of H2. All of this done with no calculator. Okay, so that would be volume to, that would be mass to volume. The last one is volume to volume, and like I said, this one is going to be ridiculously easy for you guys. The definition is you're given the volume of one gas and asked to determine the volume of another in a chemical reaction. Your steps are the volume of, convert the volume of the starting substance to moles. Okay, and if you remember, we're going to have to bring that to the front. Now, if we're going to convert from liters to moles, we would divide by the 22.4 liters per mole. And if we're going to convert from moles to liters, we will multiply by 22.4 liters per mole. So let's slide that off. And in the meantime, in between those steps, we are going to use our mole ratio, of course, to convert between our desired substances. However, because 1 mole of any gas occupies 1 mole of any gas occupies 22.4 liters, the mole ratio equals the liter ratio. So we do not need to use our mole to mole step. But I'm going to show you what it's going to look like anyways, just for you non-believers out there that don't think we can do this. So, here's our example. How many liters of NH3 can be produced from 5 liters of H2 according to the following reaction? N2 plus 3H2 makes 2NH3. So what do? We identify the given. Given is 5 liters of H2. We identify the target, liters of NH3. And we start 5.0 liters of N2. Let's fix that. 5.0 liters of N2. No, that's H2. Still my bad. Gosh darn it. Of H2 times, convert liters to moles, 22.4 liters of H2 is going to equal 1 mole of H2. This is the mole ratio step, so we know that 3 liters of H2, 3 liters of H2 will equal 2 liters of NH3. Sorry, those should be moles. Moles of H2 and 2 moles of NH3. And then we know that 1 mole of NH3 equals 22.4 liters of NH3. And then we go through. But here's the catch. Here's the beautiful thing. 22.4 liters of H2 equals 1 mole of H2. And 22.4 liters of NH3 equals 1 mole of NH3. And these 24 cancel with that 22.4. And so we can get rid of both of those in the calculations. And that winds up being 5 times 2 over 3 is 3.3 liters of NH3. Or we do this the other way. We start with our given 5.0 liters of H2. Then, because the mole ratio equals the liter ratio, we can do 3 liters of H2 will equal 2 liters of NH3. And there we are in liters of NH3. 5 times 2 over 3 again equals 3.3 liters of ammonia. Now, there are other problems we can do. We can use all kinds of other stuff. You can convert, the mole ratio allows you to convert just about any direction, in any direction with reactions. For example, you can have grams of a substance 1 converts to how many molecules of another substance. Okay, so how would that work? Determine the 3 steps. That's going to be grams to moles of number 1 to moles of number 2 to molecules of number 2. And how would we go from moles to molecules? That's going to be times 6.02 times 10 to the 23rd, because we're molecules per mole. And that's how we get from moles to molecule, which again we have from, sorry, that may be below the line, I just realized. So, which we have from our mole island on the previous sheet. That ends chapter 12.2. I hope you guys got your notes done and this was helpful to you. And this is P-Dog signing out.